Hey everybody, so we are going to be talking about area of similar polygons. We've talked about comparing the perimeter of similar polygons, and this is, haha, going to be similar to that. All right, so at the front, what I want you to write is PAV 1, 2, 3. And we're going to talk about that a little bit more on the inside. All right, so the reason why we write PAV 1, 2, 3 is it reminds us of the units that we're working with when we're working with perimeter, when we're working with area, and when we're working with volume. You'll recall that when we're doing area, we're working with square units. So what the area of similar polygons theorem states, that if two polygons are similar, and they have to be similar with the lengths. And it's, of course, of our corresponding sides. And it's going to be shown in the ratio, and I'm going to use this ratio, A to B. Then the ratio of their areas is going to be A squared to B squared. PAV 1, 2, 3. So you want to see this. That 2 is what's coming into play here. So first you've got A to B. So say you've got the side length of polygon A, polygon 1 to polygon 2 in this picture. Your ratio is going to be A to B. Now, the area ratio is just going to be that same thing, but it's going to be A squared to B squared. All I'm doing, and let me actually change that up a little bit, is taking my side length and I am squaring it to get that ratio of the volume of the area. When we're doing it with volume, you can probably guess that it's going to be to the third power instead of to the second. All right, so let's check out some of our examples. Our first set of examples, we're going to go ahead and use it to help. We're going to write ratios, and that's going to help us find the ratio of the areas. So in this case, I've been given my side lengths. ABC is similar to XYZ. We've been given AC and XZ. Those two are corresponding sides, so we can figure out that if we are continuing with this, it's going to be 5 to 8. Or you can write it as a ratio, as a fraction. But what we've been asked is we have to find the ratio of the areas. So it's going to be 5 over 8, but we're going to square each of these. 5 squared, of course, is 25, and then 8 squared is 64. And that is the ratio of my areas right there. Yes, it's really that easy. All right, so now let's go ahead and work backwards. All right, so now we've been given two shapes, and we've been given each of their areas. We've been given BC and NO. Those are corresponding similar sides. We've been given their area, so the first thing we're going to do in order to find the ratio of the side lengths is set it up. Is 28 over 63. Then what you gotta do is you have to simplify. When you simplify, it'll be a whole lot easier for you to figure it out. Now 28 and 63, they can both be simplified by 7. 4 times 7 gets you 28, and 9 times 7 gets you 63. And now when we take the square root of both the top and the bottom, we're going to get a nicer number to work with, and we know that our ratio is going to be 2 over 9 for the side lengths. And guess what? You're done. Now, of course, it's not always going to be that easy. So if you go into that second flap, example 2, we're going to find the area. Technically, it's example 3. All right, we're going to find the area, and we're going to have to set up proportions in this. So we've got corresponding sides. We've got AB to PQ. And then we've got the area of one of the shapes, but not of the other one. And we're having to look for that area. And I'm going to label that area as X. So let's go ahead and set up a proportion. And now we know that our side length is 12 over 15. And we know that our area, it's going to be X over 325. But right now, these are not both areas that are being compared. You have to make sure that they're the same things that are being compared. You've got side lengths and area. So what we're going to have to do, we're going to use PAV 1, 2, 3. We're going to square each of these side lengths to get that ratio for us. So now the ratio that's going to help us complete this proportion is 144 over 225 is equal to X over 325. And then you do what you've always been doing, cross multiply. So I got 225X is equal to 46,800. Now you don't need to write that comma, but it helps me read the number when we're writing it. All right, so what we're going to do is we're going to divide both sides by 225. And when we do that, we're going to get that X is equal to 208. Now recall your units, because we're working with area, it's going to be your units squared. And guess what? You're done. So we've got our last example where this time you're going to be given the area ratio, but we have to find that corresponding side length. Remember, you have to have it be corresponding. So let's make sure that that's what we've been given. And it doesn't look like that KL and CD are corresponding, but if you look at that congruency statement, it actually is. We've been given CD. And CD no, I'm sorry. They gave us BC, right? They gave us CD, but KL is corresponding with BC. Well, because we're working with the area of regular polygons, I'm going to have you assume, just for this one, that these are all congruent. And if they're all congruent, then we know that this is also going to be 27 inches. So it's missing that information there. All right, and I'm giving that to you. So make sure you make a note of that. And if that's the case, then KL and BC are similar, and we can set up our proportion. And we're going to use ABCD. So we've got 27 over X is going to equal whatever our ratio is that simplifies from that area ratio. Now, what we're going to have to do to figure that ratio out is we're going to have to do 162 over 8, which was our area ratio, simplify it. When we simplify it, we get 81/4. And you have to work with the square root because these are all in A2. These are all in squared. We're working with ones. So we're going to take the square root of each of these, and we get 9/2. So this is just the square root of 81 over the square root of 4. And we don't need to worry about the plus or minus roots just because we're working with length. And now that you've got this ratio set up, okay, we can just cross multiply and solve for X. When you solve for X, you should get X is equal to 6. That means KL is equal to 6. All right, so that's all you've got. I just want you to remember PAV 1, 2, 3. Thanks for watching.